Hello, grade 8. So, I'm sure most of you have heard about the incidents that have happened yesterday in Zoom. That was yesterday, Monday. And so that's why today we won't have our normal Zoom lessons, and I'll be doing a YouTube video lesson instead, so that we don't have any random hackers coming in posting things that shouldn't be posted on our lesson. So we will be doing 7.6 today. I'm splitting this lesson into two parts. So this is going to be part 1, 7.6 inequalities, part 1, and we'll be talking about adding and subtracting in inequalities, and then in part 2, we'll do multiplying and dividing in inequalities. So first of all, what is an inequality? Inequality means that it is not equal. So inequality basically means it is not equal. And so in an equation, if something is not equal to something, it must be either bigger or it is smaller than something. Inequality means it is not equal. So either bigger or smaller. And so let's start with a very simple example. If we say that x is a variable, and then I also give it an extra rule, and the rule is it has to be smaller than 12, for example. Then I can write this as an inequality. This will be an inequality x is smaller than 12, like this. And so here is our x. This means smaller than, and then we have 12 over here. That means x can take any value from 11.9, 11.8, 11.7, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and even go negative. And so x can take any value that is less than 12. So what this means is x can take any value that is less than 12, not including 12. Okay, so not including 12. And so we can also do something called graph an inequality. So if we're going to graph an inequality, so graphing an inequality, graphing inequality. So if we have x is less than 12, we can graph the inequality on a number line, graphing inequality on number line. And so what I would do is I'm going to draw a number line. Let me take out my ruler over here, and then I'm going to draw a straight line like that. And then let's say that this in the middle over here, let's say that we have just 12 is over here, and so we have 11, we have 10, we have 9, 8, 7, and so on. This goes on forever. And then also in our number line we have 13, we have 14, and so on. If x is smaller than 12, then what we would do is smaller than 12 does not include 12. And so on 12, we would draw a hollow circle. So it has to be hollow. Hollow meaning not inclusive. Hollow means not inclusive. And then we would then draw a line this way saying that x can take any value that is less than 12, not including 12. And so that's what it means by x is less than 12. Now, let me do another example. Let's say that we have an inequality that x is greater than 3, for example. This is just a random example. And so if we want to draw a number line, let me draw a number line over here. This means that x can take any value that is bigger than 3, not including, because I said that x is greater than 3. 3 itself is not greater than 3. So I would just start off by putting 3 over here, and then I can put 2, I can put 1, and so on. And then we have 4, 5, 6, 7, 8, and so on. And so if it's not inclusive, if x is greater than 3, then we have to draw a hollow circle at 3. and then we do a arrow that goes to the bigger side. That means that x can take any value that is greater than 3. And of course, this is not including 3. So from 3.0001, that's fine because it's not 3 exactly. As long as you are bigger than 3, then that's fine. And then there are 2 other inequalities that I haven't included yet, so I'll start mentioning about it. The first one, let's start off with, what if we have x and we say that it is less than or equal? So this symbol over here means that it is less than or equal. So let me just quickly label that. That's less than or equal to. So let's say that x is, this time it's less than or equal to 10, for example. That means that x can take any value that is smaller or equal to 10, including 10. So this time it's including 10 because it is or equal to. That means x can be 10 or 9, 8, 7, 6, 5, 4, 3, 2, 0, or negative. It can go to the negatives. Negative infinity, that's also fine. But the moment it goes above 11, x cannot take that value. And so if we're going to graph that, this time, let's do another number line over here. Let's say that 10 is here, and we have 9, 8, 7, 6, and then that's 11 and 12. If it's inclusive, then we draw a solid dot on the 10, and we know that x can be less than or equal to 10, and so our arrow would go towards the left, saying that it can take any of the values on the left side of 10, which is less than 10. And so if it's inclusive, it will be a solid dot. Solid means inclusive. It includes the value itself. And so now we have our last example. Let's say that x is greater than or equal to, we haven't done any negative numbers, so I'm going to go into our negative numbers over here. Let's say that x can be greater than or equal to negative 5 as an example. That means that x can take any value that is greater or equal to negative 5. Of course, that is also including negative 5 because it is greater than or equal to. And so with this, okay, so this symbol over here means greater than or equal to. And so with a number line, let's say that negative 5 is over here. Negative 5, we have negative 6, we have negative 7. And the more left we go, the more negative it is. And then the more right we go, the greater it is. So we have negative 5, we have negative 4, we have negative 3, we have negative 2, we have negative 1, we have 0, and we have 1. And if we continue, it goes to 2, 3, 4, 5, 6, 7. And so this is inclusive. And so I'm going to draw a solid dot right on top of the negative 5, and then I'm going to draw an arrow that goes to the right, which means that our x can take any value that is bigger than negative 5. So these are what we call inequalities. Now, looking at, before we go to the homework, I'm not going to give you your homework yet. Let me just continue on with adding and subtracting in inequalities. So let's just say that we have an inequality, a very simple one, that in adding and subtracting, let me just do that, adding and subtracting in inequalities. And so over here, over here, let me just give you a very easy example. we all know that 5 is less than 10. This is a no-brainer. It's definitely less than, because there's no way that 5 is bigger than 10. This is just a given fact. And so what I can do to the inequality is I can actually add or subtract numbers to it. So for example, just like normal equations, if I add 3, let's just say if I add 5 to both sides, what will happen? So if I plus 5 to both sides, let me do that in green, plus 5 and plus 5 to this inequality, we would have here 5 plus 5 will be 10, and then let me keep the less than, 10 plus 5 will be 15. Is this statement still true? 10 is less than 15? Yes, it is. It is still true. And so, whatever we add to one side of the inequality, we must add to the other side of the inequality to make sure that inequality still stays true. So, make sure we add or subtract to both sides. So this is universally true. If I add to the left, I also add to the right. If I take away from both sides, so let's just do this in blue this time. Let's say I want to take away 10. Minus 10 to this side and minus 10 to that side. And so 10 minus 10 will become 0. The less than will be the same. 15 minus 10 will be 5 this time. Is 0 still less than 5? Yes, 0 is certainly less than 5. And so this inequality stays true. It is still correct. Now, how does this go into solving inequalities? Let's say that we have, for example, x plus 5 is less than 15. Now, this is an equality including variables. So what we have here is a condition that on the left side, we have an expression of x plus 5, and on the right side, we have another single expression of 15. And this says that x plus 5 must be less than 15. That means that if we look at a number line over here, let me just put 15 over here like that, 15, 16, and then we have 14, 13, 12, 11, 10, and 9. That means that our x plus 5 must be less than 15. That is what our x plus 5 means. And so what value can x plus 5 be? If we just think about it, if I put in x as equal to 10, that means x plus 5 will be 15. Is 15 less than 15? No, 15 is not less than 15, which means that x cannot be equal to 10. It must be smaller than 10. If we think about 9.9, for example, and 9.9 plus 5 will be 14.9, it is still less than 15. And so we know that x will be less than 10. Now, how do we do this mathematically in these equations? Well, what we can do is we can think of it as solving the equation. So we want to isolate x by taking away 5 from both sides. So I'm going to do that over here, minus 5 from both sides. And so once we take away 5 from both sides, we have x is less than 10. And so we have solved our inequality over here that x must be less than 10 in order for our original x plus 5 is less than 15 to be true. So that is solving an inequality. Let's do some other examples. So I'm going to give you 4 example questions over here. Example questions. And so what you have to do over here is you must solve the inequality. Finally, if going back to our previous example, if we want to graph the solution, we graph the x, not the x plus 5. So a while ago, I wrote down x plus 5 is less than 15. But finally, when we get to the answer, we need to graph a inequality graph, graphing the solution. So we're going to put 10 over here, 9, 8, 7, 6, 5, 4, and so on. And we have 11, 12, and so on. then what I would do is if x is less than 10, of course, it will be a hollow dot on 10. And then I'm going to draw an arrow that goes to the left side. So that's graphing my solution. Going back to our example questions over here, I'm going to give you 4 questions. So A, we have x minus 3 is greater than or equal, this time is greater than or equal to negative 1. And then B, we have 6 is less than t minus 5. And then in C, we will have w plus 9 is less than negative 4. And then in D, our last one, we have 1 is less than or equal to k plus 7. Now, what I encourage you all to do is to try your best to do these on your own first. Now, if you get stuck, if you don't know what to do, then you may continue watching the solution, but I want you to try first. At least, if you don't understand the first one, then watch how I do the first one, then you continue to pause the video, and then you try the second one, the third one, and the fourth one on your own before you watch how I do the solutions. So please do these 4 questions on your own first. I will go through the answers when you are done. So I assume that you should have finished. If you didn't pause the video, then you should pause it now and do the questions. I'm going to go through the answers right now. So what I want to do in A is we want to isolate the variable x. We want to move it, we want to make sure that it's on its own to find out what x is greater or smaller or less than or something like that. So we see that we have an x minus 3. Just like in normal equations, I'm going to add 3 to both sides, plus 3 and plus 3 to both sides. And so what happens here is we will have x is greater than or equal to negative 1 plus 3. I'm going to show all of my working out. And then negative 1 plus 3 will be positive 2. And that means that x is greater than or equal to 2. My inequality sign isn't going to change yet. We're not going to change it in this lesson. It all stays the same in adding and subtracting. Next lesson, when I teach the multiplying and dividing, then we will start to switch inequality signs. That's when it's going to get a little bit confusing. But if x is greater than or equal to 2, if we're going to graph this, then we will have 2 over here. Let's 1, 3, 4, 5, 6. And then I'm going to draw a solid dot because it is inclusive of 2. It is equal to 2 as well. And then we have an arrow that goes to the right like this. Then in B, we have 6 is less than t minus 5. So we have a t minus 5. If I want to get t on its own, I want to move the minus 5 to the other side. And so when we move a negative number to the other side, it turns into plus. And so we will have 6 plus 5 on this side is less than t. And once we combine the like terms, 6 and 5, then it becomes 11 is less than t. Now, we're not used to reading these equations where the variable is on the right side. So what we're going to do, if 11 is less than t, it is actually the same as t bigger than 11. Okay, so if you swap it, make sure you completely mirror the whole equation. Make sure it still remains the same. If you're not sure whether you need to swap the sign, then just give yourself an answer. For example, if 11 is less than 15, then 15 is got to be bigger than 11. Just think about it this way. And so if t is greater than 11, when we're going to graph this solution, I'm going to put 15 over here. 11, right? 11, 10, 9, 8, and then we have 12, 13, 14, and so on. Then it's going to be a hollow dot at the 11 because it's not including 11. T is greater than 11. And then t can take all values that are bigger than 11. So I'm going to put a arrow pointing to the right because it can take any of those values on the right side of 11. So that's question B. Now moving on to C, we have w plus 9 is less than negative 4. And so we want to get rid of the negative 9 to the other side. And so plus 9 will turn into minus 9 on the other side. So w over here is less than negative 4 minus 9. And so once you combine the like terms, w is less than Negative 4 minus 9 is negative 13. And so once we graph the solution, let me just put 13 in the middle. And then 14 like this, 15, 16. We have 12. Oh, sorry, these are not negatives. Sorry, I need to change the order. If this is negative 13, sorry, then the more negative we go, that's negative 14 here, that's negative 15, and we have negative 16. The more left we go, the more negative it is. And then the right side is less negative, so it's negative 12, negative 11, negative 10, and so on. And so if W is less than 13, it's not including negative 13. So it's going to be a hollow dot at negative 13. And then negative less than, we can take any of the values on the left side. So I'm going to draw an arrow pointing to the left, and that is how we graph C. Then for D, I know I accidentally rubbed off part of the equation. It's 1 is less than or equal to K plus 7. And so what we want to do is we want to get rid of the plus 7 to the other side. And so plus 7 to the other side will be minus 7. And so it would be 1 minus 7 is less than or equal to K. And then again, I'm going to mirror this whole inequality. Before I do that, let's do the 1 minus 7. 1 minus 7, positive 1 minus 7 will end up at negative 6. So negative 6 is less than or equal to K. Let's think about it. Negative 6 is less than or equal to 0, for example. Like negative 6 is less than 0, for sure. And so if we swap it, 0 must be greater than or equal to negative 6. So let's put down K is greater than or equal to negative 6. And then once we have to graph this, let me put negative 6 in the middle. Then we have more negative than negative 6 will be negative 7 on the side, negative 8 and negative 9. Less negative will be negative 5, negative 4, and negative 3, and so on. And so if K is greater than or equal to negative 6, we're going to do a solid dot. This time is solid because it's greater than or equal to. And then it's pointing to the right because it can be greater than. So that's how we do these 4 questions. So hopefully we understand. Next lesson, we will continue with multiplying and dividing. But for now, please do the following questions for homework. That's not, I've set only some of the questions that are only related to adding and subtracting. And then next lesson, we will continue. So these are the homework questions, 3 to 14, all of them, and then 32, 37, and 38. If the question asks you to solve and graph, then make sure you do graph the same way that I have shown in my 4 example questions. So that is it for today's lesson, and I will see you all on the next day. I'm not sure whether we will continue having pre-recorded YouTube lessons or whether our Zoom lessons will be resumed. So make sure you check your emails for any updates from Mr. Vanderpyle. Thank you, and I will see you guys.